Assalamu alaikum, this is Walid Khashaba from ESS School of Science and Engineering, American University in Cairo. Today, inshallah, is our first class. We'll cover part of the analytical geometry and trigonometry. I hope you will enjoy the coming few minutes. Well, let's start with the first type of equations we're going to deal with, which is the first degree equation, as you can see, in two variables, ax plus by plus c equals 0. This is a first degree equation. First degree because there's no powers affects x or y. A, b, and c are all constants, and this is going to be the general form of the equation of straight line. But we have a standard form of the equation, which is y equals mx plus b. This is also called the y-intercept or the slope-intercept form, because m, the coefficient of x, is the slope, and b or c in other books, you may found it in other books, y equals mx plus c. They are the same. Well, b here is the y-intercept, or the cut part of the x-axis, which represents here in the graph with the word rise, this distance from the origin to the point of intersection between the line and the y-intercept. Well, the slope can be founded in many ways. For example, if we have 2 points on the line, 2 points lie on the line, and we're going to assume the first as x1 and y1 and the second x2 and y2, we can find the slope using these 2 points with the rule that you have here, this rule, this one, y2 minus y1 over x2 minus x1, the differences in y over the differences in x. Also, some books name it delta y over delta x. Or if we have a graph like this, then we can find the slope using this distance over this one. Rise over run. Only rise over run. We will take the distance. It means we will never focus on the negative sign here, because we are dealing with distances. Rise over run. And after that, we're gonna study the attitude of the line, whether it is rise to the right. Here it rises to the right. Then the slope is gonna be positive. If the line was folds to the right, falling to the right, then it has a negative slope. Well, we can also generate the equation of a straight line knowing the slope and 1 point. The slope and 1 point using this final equation here. Y minus y1 is equal to m, which is the slope, times x minus x1, where x1 and y1 is the point lies on the line. Well, so we have a relationship between any two lines on the graph. If these two lines were parallel to each other, then the slopes must be the same, must be equal. And if these two lines were perpendicular, perpendicular makes 90 degrees, like this, 90 degrees. Then the slopes would be in this, m1 equals negative 1 over m2, or the slope of one of the lines will be the additive inverse of the reciprocal of the other. Reciprocal means the multiplicative inverse of the other. The additive inverse means if one of the lines has a positive slope, then the perpendicular line on it definitely going to be negative. Its slope will be negative, of course. This is if these two lines were perpendicular, but if they were intersected, but the angle between them is not 90 degrees, we can find the measure of this angle using this equation. This equation is alpha represents the angle between the two lines, can be found easily using this equation, which is arctan, of course using the calculator, arctan m2 minus m1, the difference between the slopes, over 1 plus their product. The difference between the slopes over 1 plus their product. There's no need to memorize all these rules, because all of them, especially the little bit difficult one like this one, will be written and available in the actual test. Because as you may know, the screen in the actual test will be divided into two equal halves. The left hand side will include the reference handbook. This reference handbook is, as I told you before, it's a PDF, researchable PDF. It means that you can type just angle between two lines, and you will find this rule in just a second. That's why there is no need to memorize all these rules. Of course, if you know it, it will be better and time safer, of course. Also about the calculator. If you forgot to bring your calculator, it will be available on the screen. Texas Instrument, but I don't remember the edition of this calculator. But it's a very scientific and helpful calculator. Well, let's move to the next slide. This is an example about the distance between two lines, or between 2 points. Sorry. If you have this distance or these 2 points on a plane, then we can find the distance using the first rule. This one. The distance between any 2 points on a plane is the root of y2 minus y1 all squared plus x2 minus x1 all squared. Actually, it's not a new rule. It's the same as Pythagorean theory. Do you remember Pythagorean theory? It's the same. But if you are dealing with 2 points in 3 dimensions, like this example. Example here is the distance between point P and point Q. As you can see, both of them contains 3 components. Well, these 3 components can never fit in this rule. That's why we need this one. The distance in this case will be the difference between y squared plus the difference between x squared plus the difference between z squared. Simply, if we use the rule, we can find that the answer is 3 times root 114. Well, let's see if we have a quadratic equation, if we have a second degree equation. Of course, its graphical representation will never be a line, because as we should know that first degree is the straight line. We call it linear equation. But for quadratic equations, it will draw a parabola. Parabola in the U-shaped curve. Parabola or U-shaped curve. Anyway, this is the general form of the equation ax. Of course, as you can see, it's in one variable, unlike the previous equation. It was in two variables. Here, the equation is ax squared plus bx plus c equals 0. Well, there is a formula we can solve it. Of course, some of you know how to factorize it into two brackets, especially the numbers were easy. But this formula will help in any kind of quadratic equation. And we're gonna use it many times because it has many functions to do. Well, x will equal to negative b plus or minus root b squared minus 4ac over 2a. As you know, of course, a quadratic equation like this will have two solutions. These two solutions are, if you have a look on a parabola like this, these two solutions are these 2 points. I mean, the points of intersection with the x-axis, because it's from the second degree here. Means it has two solutions. Anyway, these two solutions can be founded using this formula. The first one will be negative b plus the square root, and the second one will be negative b minus the square root. And the value under the root, this value, we call it the discriminant or the determinant. Discriminator in some books and the determinant in many other books. Determinant because this expression, I mean b squared minus 4ac, will help to determine whether the two solutions are different or the same. Also, it helps in determining whether the roots are real or not. I mean, complex, of course. Well, let's see what's next. That's what I'm talking about. The types of the root. The types of the roots can be determined using this expression, the discriminant or the determinant. Well, the discriminant here is greater than 0, positive I mean. It means that we have two different real solutions or two unequal real solutions. But if it is 0, like this, then the value under the root will be 0. The solution will be only negative b over 2a. It's going to be one solution. Actually, there are two solutions, but they are the same. In this case, by the way, the curve will be like this. It's only touched the x-axis in one point. And we can call it double root. If it was negative, of course, we cannot find a real value for a negative a square root of a negative value. There is no real answer to the square root of negative value. That's why we're gonna consider the roots are complex and unequal, of course. Let's have an example. Solve the equation 2x squared plus 5x minus 4 equals 0. As you can see here, a is 2, b is 5, and c is negative 4, which is important to take the variable, the constant, the coefficient of x squared or x, or the constant with its sign. Then for x squared, it is positive 2. For x, its coefficient is 5, positive 5. But for c, the constant, it's negative 4. And of course, you can substitute in the rule to solve or to find the two values of x. You may pause and solve it using the previous rule or formula. Well, here we have another type, the general form of the conic section. You know, the intersection between a cone, that's why we call it conic sections, between a cone and a plane. If this plane were parallel to the base of the cone, we will have a circle like this one. If this plane was inclined like the ellipse, we will have this figure, this one. If the incline of the plane, or the plane will be steeper, more steeper than the ellipse, we will have parabola. Parabola is this figure, which could be, as you can see, it could be upside down or in U shape. If it was almost vertical, then we will have a hyperbola, because hyperbola is two of these figures, two opposite, like one upside, one to the in a U shape and one an N shape, two opposite parabolas. In the coming slides, we will have some rules just to be familiar with it, to know how to find the area or the perimeter of a figure or the volume, because we're gonna face some figures in the coming slides. As you can see here, part of the parabolas, here the ellipse, the rules of the ellipse. As I told you before, there is no need to memorize all these rules because it's written in the handbook. All I want to study with you, to distinguish between circular segment and sector, circular sector. This is the segment. The segment, as you can see, it's apart from the sector as a whole, but the sector is this one. This is the whole circular sector, the whole area, the whole slice. Well, the sphere as well. We have the volume and the area of the sphere. Parallelogram. There is a note for parallelogram, as you can see. If the two diagonals were perpendicular, then it could be one of two. It could be rhombus or square. Well, to know whether the figure is square or a rhombus, we have to um, know whether the diagonals are equal or not. If they're perpendicular, then we know that they're gonna be, the figure will be either a square or a rhombus. If these two diagonals are equal in length, then this figure is a square. But if they are not equal in length, then the figure is a rhombus. A rhombus is like a squeezed square. It's like a diamond. Well, regular polygon. What's meant by the word regular? Polygons, of course, any closed path contains sum of sides. For example, that triangle is the smallest in number of sides. I mean, polygon. Square, all quadratic quadrilaterals figures, it can be treated as polygons. Also, this figure that we have here, we have an octagon. Octagon means 8 sides, and pentagon, of course, is 5 sides. Hexagon is 6 sides. Heptagon is 7 sides. Octagon is this one. Nonagon is the polygons with 9 sides, and decagon is the polygon with 10 sides. Let's go back to the polygon that we have here. The word regular means all sides are equal, and also all angles, like theta here, this angle, this vertex, all these vertices are equal in measure, of course. All we have to know is to distinguish between phi and theta. Phi is the central angle from the center of the circle that inscribed on the square, or circumscribed, sorry, the polygon here, and theta is the vertex angle. These rules are to find theta and phi, to find the perimeter of the polygon and the area of the polygon, also to find the side of the regular polygon. But the word regular is very important because it provides me that this figure is equilateral and equiangular at the same time. Prisms. Prisms, like as you can see here, a rectangular prism, a pentagon prism. It depends on the base of the prism. Here's the volume of the prism. Well, cone. As you can see, the rules. The total surface area of the cone, as you can see, divided into two parts: the side area, or the lateral area, and the base area. For cylinder, the two bases, the two parallel bases are equal, are the same. Unlike the cone, it has one base and the other one just a point. Here we have two similar bases. That's why the rule here, and areas. And areas are the two circular bases of the cylinder. Paraboloid Revolution. It's do you remember parabola? If I rotate this parabola about the vertical axis, it will form this figure, this paraboloid of revolution, and it has a volume, as you can see, which is pi d squared. D is the diameter of the circle formed by rotation times height over 8. Anyway, let's go back to the conic section. After we knew the rules of area and volume of each of the previous figures, here we have something called eccentricity. What's meant by eccentricity? Eccentricity shows how the figure is uncircular. Uncircular means it's almost like an oval. If we're gonna know how to determine whether the figure is a circle, an ellipse, parabola, hyperbola, the figures that we talked about. Well, let's start with the first case. If the eccentricity is E. The eccentricity is a ratio. You may know it from the previous slide. It's a ratio between the angles theta and alpha. Anyway, this is the standard form of the parabola. The eccentricity here is 1. The ratio between the angles are the same. This is the standard form. The center of the parabola is h and k, and please note that h here in the rule have negative sign. Also k has negative sign as well. Anyway, we have to be familiar, just to be familiar with this figure and the focus and the directrix of because we're gonna face in the coming slides, we're gonna face questions about how to determine the type of the figure or the curve, whether it's parabola, circle, ellipse. Then we have to know its general or standard form of the equation of each type, and to determine whether it's an ellipse, parabola, by using the eccentricity. Here the eccentricity is 1, then the figure is a parabola. And if the eccentricity is less than 1, then the figure is an ellipse. Of course, with the standard form, as you can see, it's unlike the previous one because it's a fraction, x squared over a squared plus y squared over b squared. The eccentricity is c over a. C is as you know, if the eccentricity exceeds 1, then the figure will be hyperbola. As you can see, as I told you before, the hyperbola is the figure of two opposite parabolas, as you can see. All we have to focus on is the sign between the two fractions here. In parabola, in ellipse it was plus, in hyperbola it is negative, as you can see. The eccentricity is 0, it means that the figure is totally circular. Well, this is the standard form of the circle, and h and k, of course, are the centers of the coordinates of the center of the circle. Radius can be found using this formula, this one here. Of course, that's again the Pythagorean theory. Well, and this is a rule to find the length of the tangent between a point outside the circle and the point of tangency of the circle. Again, it's another application to Pythagorean theory, because we know that this angle is 90 degrees. Well, let's have a summary. If the eccentricity is 0, then it's a circle. If it is between 0 and 1, less than 1, it's an ellipse. If it is exactly 1, it's a parabola. If it exceeds 1, it means that we have a hyperbola. Of course, if the eccentricity is infinity, something over 0, then we have a straight line. Well, this is the general form of the conic section equation. How can we determine it? We can determine this equation. It's from the second degree, of course, as you can see, because of the powers here, but it's unlike the parabola. It is in two variables, x squared and y squared. Okay. Of course, A and C should never be 0, because if they were 0, it will be from the second degree, but unlike this, it will be only bxy plus dx plus ey plus f. Well, again, do you remember this term, this expression, b squared minus 4ac? In this case here, it's going to be also the discriminant, but to determine the figure of the conic section that we have. If this if this discriminant is less than 0, then we are dealing with an ellipse. Well, if it is greater than 0, then it's a hyperbola. If it is equal to 0, then we are dealing with a parabola. Well, if A and C are equal, A and C, the coefficients of x squared and y squared, are equal, and there's no such term like bxy is equal to 0, because b in this case will be 0, then we are dealing with a circle. Okay? Of course, if all of them, all the second degree terms, x squared, bx, and y squared, are disappeared, and this of course will happen only if A, B, and C are equal to 0, then we are dealing with a first degree equation, only bx plus ey plus f equals 0, then we are dealing with a straight line. Well, this is the equation that you know. These expressions, I mean a squared plus b squared minus c, is just to determine the center of the curve. It's the center, whether it is on the x-axis, or because it has a principal axis. Any figure of these has a principal axis. It doesn't mean that it should be on the origin, or follows the same axis that we know, the y-axis and the x-axis. It could have another axis. We will know for an ellipse, for example, or hyperbola, whether the center lies on the x-axis or the y-axis. You know, all of this. Well, let's start with example 1. Classify the graph of each general quadratic equation in two unknowns as a circle, parabola, an ellipse, or a hyperbola. Here, as I told you before, we have to be familiar with the shape of the equation, the standard form of the equation of each of the four figures: circle, parabola, ellipse, or hyperbola. Let's start with the first one. A 4x squared minus 4xy plus y squared minus 5 root 5x plus 5 equal 0. Well, as you can see here, A is 4, B is negative 4, C is 1, which is the coefficient of y squared, is 1. Then the discriminant, which is b squared minus 4ac equal 0. Then we are dealing with parabola. That's what you should focus on. The discriminant. The purpose of discriminant is to determine the figure of the curve. If it was 0, as you know, then it's a parabola. For the second one, now let's see B. As you can see in the equation, 8y squared plus 6xy minus 9 equals 0. There is no A, then A is 0, because, as you remember, A is the coefficient of x squared. Then the discriminant will be b squared minus 4ac, which is 6, only 6 squared, because the term negative 4ac will be 0, because a is 0. Then when I multiply 0 by 8, it will be 0. Anyway, b squared is going to be 36. It means that it's greater than 0. Also, it means that the figure is a hyperbola, as you can see. Well, example 2. Determine the coordinates of the vertices and the foci of the conic section defined by each equation. And here we have two equations. What I want you to be familiar with the format of the equation. We have to focus on the format. Here it was only x squared plus y squared, or only the x squared minus y squared. There is no such terms like first degree, like x, y, or even xy. Then these two equations will be one of three graphs or things, either circle, ellipse, or hyperbola. That's why we have to focus on these three things. Do you remember the standard form of the equation of ellipse or hyperbola? Well, no problem. Let's have a look again on the first one. The equation of the ellipse or hyperbola, the right hand side, this one is always 1. That's why you have to divide both sides by 144 to make the right hand side is 1. As you can see in the solution, after we divide both sides by 144, the left hand side will be x squared over 3 squared plus y squared over 4 squared. This is the standard form in case of h and k were zeros. H and k are, or a and b, the values, the constants associated usually with x and y in one bracket. The moment you see x squared, only x squared and y squared, it means that this graph is centered at the origin, because there is no shift to the right or to the left. Anyway, and the vertices of the y-axis, on the y-axis, why? Because the constant under y is the greater, it's 4. That's why it's centered on, the vertex is on the y-axis. And the coordinates of this vertex, of course, is positive 4 and negative 4, the square root of the constant under y squared, which is positive 4 and negative 4. This is all about the graph, the center, and the coordinates of the vertex. Now, let's study the coordinates of the foci. The center to focus distance is C, between the distance between the center and the focus. C can be founded, again, the same idea like Pythagorean theory. It's the square root of 4 squared minus 3 squared. 4 squared minus 3 squared is the square root of 7. Therefore, the coordinates of the foci will be 0 and root 7, and also 0 and negative 7. These are the two foci. The focus to the right of, root 7 and negative root 7. On the y-axis, as we said, why? Because 4, the value under y, is larger than 3, which is the value under x. We will follow the same technique for b. Well, first of all, we're going to divide both sides by 144, as I told you before, to make the right-hand side as 1. Now, let's have a look on the values under x and under y. Under x, it remains 3, but under y now is negative 4 squared. Then, again, it's centered at the origin because there's nothing plus or minus x or plus or minus y. That's why it's centered at the origin. And the vertex will be on the x-axis right now. Why? Because the value 3 is larger than negative 4. Okay? Anyway, it's going to be 3 and 0, of course, and negative 3 and 0. The distance between the center and the focus of the curve, it's a hyperbola because the negative sign between x and y, it's a hyperbola, unlike the sign between x squared and y squared was positive, that's why it's an ellipse. So the center of the distance between the center of this hyperbola and the focus of hyperbola is c, again, which is the square root of 3 squared minus negative 4 squared. It will be positive 4 squared, then it's going to be 5. Therefore, the coordinates, of course, on the x-axis this time, it will be 5 and 0 and negative 5 and 0. I hope you understand this example because I want to focus on the shape of the equation, the type of the equation. If you know the type, you will save a lot of time. Well, question 3 or example 3. In each case, determine the general quadratic equation of the conic section, the general quadratic equation. That's it, with the given characteristics. The first one is a parabola, vertex at the origin, and focus at negative 2 and 0. The second equation is for a hyperbola, asymptotes along the x-axis and y-axis, and passes through the point 3 and 2. Let's start with A, the parabola, with vertex at the origin and focus on the x-axis had the form y squared equals 4px, where p is the coordinate, p and 0 of course, is the coordinate because it's focus on the x-axis, then the y coordinate should be 0. The point P and 0 is the coordinates of the focus. Since the x-coordinate of the focus is given by -2, then simply we're going to put -2 instead of P. That's it. Direct substitution. Then all we have to know is this equation and the center of the coordination of the focus. As you can see, it's very easy. It's all about equations. That's why you have to be very familiar with these equations. There's no need, of course, to memorize it, as I told you before, but if you study it by heart, it will be always here. There's no need to search on it. Wait. Let's go back to the equation. It's gonna be y squared equals, and instead of p, I'm gonna substitute p with -2. Then y squared is equal to -8x, or y squared minus 8x equal 0. For the second equation, it's a hyperbola, of course, where the asymptotes along the x-axis and y-axis is in the form xy equals k. That's it. Only xy equals k. We know that the hyperbola passes through the point 3 and 2. That's why you're gonna playing 3 instead of x and 2 instead of y. Then xy will be 6. Then the general quadratic form will be xy equals 6, means that k is 6, or xy minus 6 equals 0. The final example is about the circle. We have covered in the previous couple of slides parabola, hyperbola, and ellipse. Now it's time to see an example about circle, of course. Here's the given. A tangent to the circle with center. The center coordinates is 1 and -2 here. 1 and -2. And the radius is 3 here. And the tangent passes through the point 5 and -5. Well, first of all, find the equation of the circle. Do you remember the general form? You have to remember the general form of the circle, the equation of a circle. Second, you have to find the distance here. We want to find the distance between point P and point Q, the length of the tangent from a point outside the circle to the point of tangency. Well, this is the equation of the circle. As you remember, it is x minus h all squared plus y minus k all squared equals r squared. Well, the radius here is 3, that's why it became 9. And the center is 1 and -2. The coordinates of the center is 1 and -2. Then if we put 1 here, the sign will be the same, unchanged, I mean, to be negative. But if we put -2 here, the the equation of the circle, we remember that the equation was y minus a all squared. Minus, it contains already negative sign. Then negative times negative 2, it will be positive 2, as you can see. This is about the equation of the circle. But for the length of the tangent, of course, there's no need to follow a certain rule. As I told you before, we can follow the Pythagorean theory. We have this length, which is 3, right? And the distance between 1 and negative 2 and 5 and negative 5, using the ordinary rule, which is the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared, we can find that the length of this side is 5. Then, using the very famous triangle of Pythagoras, it's going to be 5 squared minus 3 squared, which is 4. That's it. And this is all for this session. I hope you enjoyed all the, not new information, all the information that we have covered. And please, again, try to be familiar with the equations of circle, parabola, hyperbola, and ellipse, just to know where to use the discriminant or where to just determine the figure, determine the shape of the graph from the first side. Have a nice time.